All right, so here is the test review. So the first ones, it's asking you to fill in the empty blocks in the following table, complete the graph where appropriate. All right, so for the first one, it gives us set builder. It says x such that x is less than or equal to 4. So I'm gonna put the number 4 right here, draw an open circle, but since we have an equal bar, that means that the circle is closed. And since it's less than, we shade to the left. Now for interval notation, you want to go from least to greatest. Well, this arrowhead right here heads towards negative infinity, and it stops at positive 4. So my least value is going to be negative infinity, and my greatest value will be 4. And negative infinity, positive infinity will always get parentheses. And 4 is a closed circle, so we use a bracket. So in case you've forgotten, open circles and infinities are parentheses, and closed circles are brackets. All right, let's take a look at number 2. So for number 2, they give us interval notation, which is from 2 to infinity. So for 2, I'm going to put an open circle, and the number 2, and since it's a parentheses, open circle stays. This one says it goes from 2 to infinity, so that means we shade to the right because that heads towards positive infinity. Next, we're going to do set builder. Braces x such that, and like I told you before, I consider this to be my x here. One way you can think about doing it is you start from this number 2, and you can say that 2 compared to x, we can see that 2 is actually less than x, and we don't put an equal bar because it's an open circle. So you can write it like x such that 2 is less than x. Another way to write it is x first, and we know that x is greater than 2. So you can tell the inequality symbol still faces the x in both of them. So either one would be acceptable. All right, for number 3, this is a segment they give us. So they give us the graph, and we have to come up with our set builder and our interval notation. So for set builder, braces x such that. So we start with the smaller number, and I'm going to put x in the middle, so we represent the shaded region by x, and then 6 is the closed circle at the end. So we start with the number 2. And we compare 2 to x, and we can see that 2 is less than x. And there is no equal bar because that's an open circle. Now we're going to take x and compare it to 6, and we can see that x is less than or equal to 6. And when we do our interval notation, it's just from least to greatest. So my smallest value here, we can see open circle at 2. And then we have a closed circle at 6. So open circles, parentheses, closed circles, brackets. All right, and for the last one with this interval and set builder notation, so they give us this. So we're going to plot this 2 first, and then we have 3, 4, 5. 2 is going to have a closed circle because it has a bracket, and the same thing with 5. 5 is going to be filled in because it has a bracket. Now, it's the first one says from negative infinity to 2, so we know it's coming from the left side because that's where negative infinity comes from. And the other one goes towards positive infinity, and that's to the right. Now for set builder, this one is a little bit longer to write. So braces x such that, and once again I consider this to be x. Recall, we don't use infinity or negative infinity with set builder, only with interval. So right here I should not have no infinities. So we start with this x. X is, and we're going to compare it to 2. X is less than 2, and I'm going to make it equal to because the circle is closed. Or x is, so we can tell that 5 is less than x, or we could say that x is greater than or equal to 5. Okay, and if you wanted to write it 5 is less than or equal to x and put it there, same answer. All right, now we're going to move to domain and range given functions. So for this one here, for number 5, domain, we read it from left to right. So when I start from my furthest left, I have an open circle here. And that value is 1, 2, 3, 4, negative 5. And as I trace the graph along, I can see we have at the very end an arrowhead, and that goes to the right, so it continues along the x-axis parallel to it, or not parallel, but just moving in that direction slowly. So this arrowhead moves towards positive infinity. So I like to do interval notation here. So we're going to say -5 is my smallest value, infinity is my larger value, open circle, that's a parentheses, infinities, always use parentheses. Now from the range, we start from the bottom and go to the top. So as we move from the bottom to the top, our first stopping point is this right here, this curved part of the graph. That is the lowest part. Since there's no open circle, you assume it to be closed. And that's at -2. And then if we follow the graph, this is 1 point, but it's not the highest. We have an arrowhead, which means it goes towards positive infinity. So least to greatest, -2 is smaller than positive infinity. And -2 is a closed circle, so that's going to be a bracket. Infinities always have parentheses. All right, for the next one, we have a closed circle as we move to the left right here. And we have a closed circle right here, and they are connected. So this is -1, 2, 3, 4, -5 right here. And this one is at -1. So once again, this is domain. That's why I am using the x-axis. Now there's a break in the graph. They're split apart, so I'm going to use U for union. And then it starts back up at this closed circle at the value of x for 2. And if I trace it, we have an arrowhead at the end that goes towards positive infinity. So notice the way we write it. If we just read it from left to right, it is least to greatest. So we have -5 and -1. And we can see that both have closed circles, so both should be brackets. Union, we start with 2, that's a closed circle, so bracket 2, comma, and it heads towards positive infinity. And that's a parentheses. Now for the range, start from the bottom. Again, these are not the lowest points. The lowest point is going to be this curved part of the graph, which is going to be a closed circle. And then if we trace it, they both end at this both point right here, and they're both closed. So that's going to be another closed circle, and they are connected. So this value for y is 2. This value for y is, this value for y is 0. This one is 2. Then notice we have a break in the graph, so we know we're going to use a union. Then we have a closed circle right here, and that looks like +4. At the very top, we have this arrowhead that heads towards infinity. So when you write your answer from least to greatest, we start at 0, comma, we stop at 2. Both of them have closed circles, so that's going to be brackets on both. Union, and we start at 4, and we go to infinity. Infinity is all the parentheses, and this 4 is a closed circle, so that's a bracket. So there's your domain and range for 5 and 6. All right, for number 7. So we're given, it says find the range when the domain is -2, 3. So here I'm just going to make a table. It's an interval because we have brackets and parentheses. So we start at -2 and we count whole numbers or integers to number 3. So -2, -1, 0, 1, 2, and 3. These are the x values, these are the y. So to get my y values, we're going to take these values like -2, -1, 0, and we're going to plug them in right here for x. So I'll just set them up. So -2 times -2 plus 1. And I'm just plugging in these x values and setting it up. And there we go. All right. So negative times a negative is positive. 2 times 2 is 4. 4 plus 1 is 5. Then we have -2 times -1 is 2. 2 plus 1 is 3. -2 times 0 is 0. 0 plus 1 is 1. -2 times 1 is -2. Plus 1 is -1. -2 times 2 is -4. Plus 1 is -3. And then -6 plus 1 is -5. All right, so if you can't visually see how to get the range, I suggest you draw a graph. And you plot these points the best you can. So we have one at -2, and 1, 2, 3, 4, 5. And -2 has a bracket, so that's going to be a closed circle. And we're going to plot the rest of these: -1, 3, 0, 1, 1, -1, and then 2, -3, and then 3, -5. And this one right here has a parentheses, so that's going to be an open circle. And so we see our line segment, and we also see from least to greatest. Least is going to be at -5, and that's an open circle. So we use parentheses. And my highest will be 5, positive, and it's a closed circle, so we use a bracket. And that's going to be an interval because of the way the notation is written from the beginning. All right, for number 8, it's a little bit different. So for number 8, it says find the domain given the following range. So we know that range is y. So this time, instead of substituting in for x, we're actually going to plug in for f of x, which is y. The second thing I want to talk about, this was continuous. This was an interval. And this is discrete because the braces means that it's a list or a set of individual numbers, right? So -4, 0, and 6 are the only 3 numbers, whereas here we had an infinite amount of numbers between -2 and 3. So first, to solve this, I'm going to take this function 3x minus 12, and I'm going to set it equal to -4. Then I'm going to take that same function and set it equal to 0, and then I'm going to set it equal to 6. And then to solve this, we first add 12 to both sides. So 3x is equal to 8, divide by 3, and my first value is going to be 8/3. I'm going to put that in braces. Same process, we're going to add 12 to the other side. I'm solving the second one now. 3x equals 12. Divide both sides by 3. And this time, 12 divided by 3 is 4. And the last one, we're going to do the same thing. We're going to start by adding 12. 3x equals 18. Divide by 3. And x equals 6. And there is your list of numbers in the braces, which is going to be your domain for number 8. All right, let's keep going. All right, for this one it says, given the graph of f of x below, find the following. So we talked about this during class. When we're looking for a constant increasing or decreasing, we always want to use parentheses. Now it does say on what intervals of x, so make sure you are relating it to the x-axis, not the y. All right, so where is it constant? So that means from left to right, as x increases, y remains the same, it remains constant. So I see 2 parts where that's happening. I can see it happens here, which appears to be -1. And this one here, which is, oh, sorry, that's 0. Sorry, it's a -1, 0. And this is 1, 2, 3. So our first value where it's constant is going to be from 0 to 3, so 0, 3, and make sure you use parentheses. Now I'm going to use a union because I see right here that it's also constant. So union, and this value right here is going to be 6. And this one actually goes to infinity because it's a arrowhead. Now we have 6 to infinity. And always use parentheses for increasing, decreasing, and constant. I'm going to go ahead and stick with the increasing and decreasing and constant. So let's go and do increasing here. So the question becomes, where does this graph increase? So we always read graphs from left to right. So if I read this from the left, this right here is increasing all the way to this point here. Now once again, it says intervals of x. When compared to the x-axis, this heads towards -infinity. And this one right here, actually for x, is 0. And that's why I'm always using parentheses. Now for where is it negative? So negative and positive. Positive is where the graph is above the x-axis, and negative is where the graph is below the x-axis. So in this case, when intervals of x is f of x negative. So where does this graph fall below the x-axis? So the first thing I notice, when we have this arrowhead, this is all negative, 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 negative. And once you hit the x-axis, if you recall, that's going to be neutral. It's 0. It's not positive or negative. So we know it's negative from -infinity to this x value of -2. And use parentheses. Now I put a parenthesis on -2. I don't include it because it is 0, which is neither neutral, which is neither positive or negative. It's neutral. Now, once we get above here, this is positive, 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 positive. But once I get to this x-axis again, at value of 4, that is not included. But every point that falls below this heading towards infinity for x, these are all negative values. So we have union from 4 to infinity that are going to be negative. All right, next thing for these intervals, f of 0, if you recall, we're talking about f of x equals to y. So if I give you this value, I have x, and I want you to find y. And if I give you y, I'm asking you to find x. So we go to x is 0, and if we go up, we see we hit the graph right here at this point, and at that point, y is 2. For the next one, f of 8, so I get here at 8, I go down to the graph, it hits it right here, the y value is 4. This time it gives me y is 0. So if I go over here, it's this red line. And notice it hits the graph twice. So I'm trying to find x. So the first one, x equals -2, because that's where they intersect. And x equals 2, 4. So those are my two lists of numbers. So that's why I'm using braces to represent those two x-intercepts, where y is 0. All right, the next problem we have is number 10. Alexandra was skydiving. The airplane was cruising at an altitude of 12,000 feet. When Alexandra begins her jump, she free falls at an average speed of 200 feet per second for 15 seconds before opening her parachute and the canopy ride at a speed of 20 feet per second. Okay, so for this one here, we have an airplane cruising at 12,000 feet, so we'll call this altitude. And the current altitude is 12,000 feet. Then we have her on the airplane, and we'll talk about time. So the airplane was cruising at an altitude of 12,000 feet. When Alexandra begins her jump, she free falls at an average of 200 feet per second for 15 seconds before opening her parachute. All right, so pretty much what I'm going to do is I'm going to take, let's see, we're going to take 200 and we're going to multiply that by 15. So 200 feet is how much she's traveling per second times the number of seconds, which is 15. And if we do this, 200 times 15, we get 3,000. Now, 3,000 is not the altitude. 3,000 is the distance this person has fallen during the free fall. So we're going to take the 12,000 and we're going to subtract 3,000 from it. And 12,000 from 3,000 is going to be 9,000 feet. So in terms of the free fall, they fell from 12,000 feet to 9,000 feet. And the question becomes, how long did they take to do that? Well, it took them 15 seconds. It took Alexandra 15 seconds to get that far. All right, that's for the free fall as well. All right, the next part is going to be, how about the canopy ride? Well, for the altitude, that's pretty easy because once they pull the parachute, they're going to go straight down to 0 feet when they land, and the canopy ride ends. Now, how much time is passing by from 9,000 to 0 feet? Well, it says before opening her parachute, and the canopy ride is going at a speed of 20 feet per second. So how much time has passed at 9,000 feet going 20 feet per second? Well, we take 9,000. We divide that by 20. And we get 450 seconds. So in this case, it's going to be 450 seconds for the canopy ride. And that's what we have so far. And now these are the only numbers we need. We need the 12,000, 9,000, 0 for the altitude, and time is 15 and 450. So the first one says, what is a reasonable domain for the time that Alexandra will spend in the air? Well, time is measurable, so we're going to have a interval. And we know it's going to be from 0 seconds to, now, how do I get the second value? Well, 450 seconds plus the 15 seconds for the free fall, which gives us 465 seconds total. What is the result range for the altitude of free fall? Well, the two numbers that represent the free fall are going to be 9,000 and 12,000. And if you recall, those two numbers, when you're writing interval notation, they need to be put from least to greatest. So in this case, instead of 12,000, 9,000, we start at 9,000, and we end at 12,000 feet. I'm going to put brackets on both of them. Now, I've talked about this in class. This bracket right here on 9,000 will dictate the answer for the canopy ride. Now, what is the reasonable range for the altitude of our canopy ride? Well, that's going to be from 0 to 9,000 feet. Now, since 9,000 feet is included in the free fall, we can't include it here, so we put parentheses. But if you decided to put a bracket on 9,000 down here, then up here 9,000 for the free fall would have a parentheses. And the last question says, what is a reasonable domain for the time she spent free falling? Well, free falling, it literally says she was in the air for 15 seconds. Reasonable domain for the time she spent. Honestly, this could be an interval from 0, 15, and I put a bracket on both of them. So that's what we're looking for there. All right. Next question is Tom wants to purchase several guitar picks to match his shoes. He has $23 to spend, and each guitar pick costs $1.75. What is a reasonable number of guitar picks that Tom can buy? So first off, is this discrete or continuous? Well, in this case here, we're going to say it is discrete. And the reason why it's discrete is because we count guitar picks. And it wouldn't make sense to break them apart, so we couldn't measure individual pieces like 1/4, 1/3, 1/2. But with measurements, we can. So this is going to be a discrete function because it doesn't make sense to break a guitar pick. Now it says, what is a reasonable domain for the number of picks he can buy? Well, first off, he has $23, and each guitar pick costs $1.75. So we can take 23 and divide it by 1.75, $1.75. And we come up with exactly 13.1429. Now, in terms of discrete, it would not make sense to have a decimal of a guitar pick, so we're actually going to just stop at the number 13. So what is a reasonable domain for the number of picks he can buy? Well, this is discrete, so we're going to list out the numbers. So 0, 1, 2, dot, 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 and they can actually buy up to 13 of these picks if they wanted to. All right, for the next one, it says find the range when the domain is -2, 1. Hint, you may need to graph the answer correctly. You may need to graph it to answer it correctly. Okay, so pretty much we have 2x squared minus 4. We have our domain restriction, -2 to 1. So again, I'm going to make a table. My x values are going to be starting at -2 as an interval, -2, -1, 0, and 1 because it does stop at 1. Now we're going to take these values and we're going to plug them in for x. So 2 times 1 squared minus 4. So 1 squared is 1. 1 times 2 is 2. 2 minus 4 is -2. Now we're going to take this and plug in -1. -1 squared is 1. 2 times 1 is 2. 2 minus 4 is -2. So I made a mistake here. Sorry. This should have been -2. -2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. Sorry about that. All right, for the next one, 2 times 0 squared minus 4. So 0 squared is 0. 0 times 2 is 0. 0 minus 4 is -4. I'm just trying to verify this. All right, next one. 2 times 1 squared minus 4. So 1 squared is 1. 2 times 1 is 2. Minus 4 is -2. And I'm trying to see here real quick. -1 squared is 1. 1 times 2 is 2. 2 minus 4 is -2. 0 minus 4 is -4. And yeah, that appears to be right. So I just wanted to verify that I could do those correctly. All right, next thing we're going to do is we're going to graph it. A couple of things. This -2 has a bracket, so the first one should be a closed circle, that first point. So -2, and then 1, 2, 3, 4, so closed circle. And then we're going to plot the -1, -2, 0, -4, and then at 1, -2, notice that 1 had a parenthesis, so that's going to be an open circle. So at 1, -2, it should be open. And then we just make our graph the best we can. Make sure connecting those dots. So in terms of range, it's bottom to top. So the bottom part is not these endpoints, it's this closed circle right here. And the highest is this closed circle right here. So this is 1, 2, 3, +4. And this is -1, 2, 3, -4. So the range is going to be from -4, 4. Closed circle is bracket. Closed circle is bracket. All right, let's go on to the next page. All right, so this is the most recent stuff we've been doing. So it says, given the graph to the right for the function y equals f of x, describe the parameter change and graph the transformation. So pretty much this is the absolute value function, right? If I go -3, it's +3. -2 is +2. -1 is +1. And 0 is 0. And then +1, absolute value is at 1. +2, absolute value is 2. And then 3. So there's our parent function table. All right, so we're going to write down the transformations. We're going to talk about how they're affecting x and y, and then we'll make our table. I'm not going to graph it because that's something you can easily do on your own. So this first one goes to the right 2 units because it's in the parentheses. It's being added or subtracted. We do the opposite of what we see. This plus 4 is outside, which is a k value. So maybe I should leave that. This is this is h, and this one is k. So h moves it left to right, k moves it up or down. So positive 4, so we're going to go up 4. So how do these affect our x and y values? Well, right 2 affects x by adding 2 to each x value, and up 4 affects y by adding 4 to each y value. So right here, negative 3 plus 2, negative 1. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2, then 3, and then 4. And you can verify 3 plus 2 is 5. Now for my y values, it's saying to add 4. So right here I have a 3. 3 plus 4 is 7. 2 plus 4 is 6. 2 plus 1 is 3 plus 4 is 7. 2 plus 4 is 6. 1 plus 4 is 5. 0 plus 4 is 4. 1 plus 4 is 5. And 4 plus 2 is 6, and 4 plus 3 is 7. And there is my table. Once again, you can graph these yourself. Let's take a look at the next one. So this 3 is being multiplied to f of x, so that's going to be a vertical stretch by 3. And this minus 5 is going to be down 5 units. Now, in this case, for this one, x is not being affected in any way, so x just remains the same. So that's going to be negative 3, negative 2, negative 1, 0, 1, 2, and 3. All right, for my y values, it's a little bit different. You're going to do a vertical stretch by 3 first, and then you're going to subtract 5. So pretty much what's happening is you take the y values, you multiply by 3, and then you subtract 5. So right here, 3 times 3 is 9. 9 minus 5 is 4. Next one, 3 times 2 is 6. 6 minus 5 is 1. 3 times 1 is 3. 3 minus 5 is negative 2. 3 times 0 is 0. 0 minus 5 is negative 5. 3 times 1 is 3. Minus 5 is negative 2. 3 times 2 is 6. 6 minus 5 is 1. And 3 times 3 is 9. 9 minus 5 is... 9 minus 5 is, let me double check that. 3 times 3 is 9. 9 minus 5 is 4, not 14. Sorry about that. That's going to be a 4. Alright, for the next one. Again, we're just using transformations, and then we always use this original table to manipulate. So this one right here, it's in the parentheses, it's being multiplied, so we're going to take the 1/2, we're going to flip it over, get the reciprocal, and that's 2. And since 2 is greater than 1, we know that's going to be a stretch. And since it's inside multiplied to x, that's horizontal stretch by 2. So in this case here, the only thing that's being affected is x. You're multiplying the x values by 2. But the y values, they do not change. They remain y. So let's do the y values first. 3, 2, 1, 0, 1, 2, and 3. Now for your x values, you're going to take them and multiply it by 2. So right here, 2 times negative 3. 2 times negative 2, 2 times negative 1, 2 times 0 is 0, and then back up 2, 4, and 3 times 2 is 6. Alright, so there's my table. Once again, I'm not going to make the graph. That's something you can do. For the next one, we have a negative sign on the outside. That's going to be a reflection across the x-axis. If the negative was inside affecting the x, then it would be a reflection across the y-axis. All right, this right here is x minus 3. That's going to be our h, so it's going to move it to the right 3. And then this is a positive k, so it goes up 2. And if you forgot, this is an a value that is less than 0, so it reflects across the x-axis. All right, so we have the rule. So, we don't have the rule yet. Let's take a look. So the only thing affecting x is this right 3, which is going to be x plus 3. Now for the y values, we're going to multiply them by a negative 1 first, so negative y. And then k goes up 2, that's plus 2. So first off for the x values, I'm going to add 3, so negative 3 plus 3 is 0. Negative 2 plus 3 is 1. negative 1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. And 3 plus 3 is 6. Okay, so we just added 3 to each one. Alright, then we have a negative. Let's erase that. Alright, this one we're going to do the opposite of y's and then add 2. So my first y value is 3, so the opposite is negative 3. Negative 3 plus 2 is negative 1. And I'll write this rule over here since it's a little bit too far up. So we're taking negative times the original y value, and then we're going to add 2 to it. Negative times the original y value, then we're going to add 2. So negative 2 plus 2 is 0. The next one is a 1. So we have negative 1 plus 2 is 1. Negative 0 plus 2 is 2. Negative 1 is 1 plus 2 is 1. And then we have the next one. After the 1 is a 2, so negative 2 plus 2, so that's going to be 0. And then we have negative 3 plus 2, which is negative 1. Alright, and then you can graph that yourself and you will be able to see the transformations. Okay, now we're down to this where it says name the parent functions, describe the transformation effect, and then write the equation. Alright, so this is the absolute value. If you recall, the original graph should be facing up in a V shape. So first off, we can see it's flipped down, so the correct terminology is going to be a reflection across the x-axis. Notice this dot is over here now, so it went right 3 and then down 2. Alright, I forgot to put the name, but the name is the absolute value. And last, we need the equation. So the transformation equation for this is y equals a absolute bar x minus h plus k. So in this case here, we see that reflection across the x-axis is a, right 3 is h, and down 2 is k. Alright, so y equals, since we don't, the only thing we have for a is a negative sign, we just put negative. Not negative 1, you can if you want, but just negative is good. Absolute bar x minus, right 3 is going to be minus 3. And then down 2 is minus 2. So there is your transformation equation, given those transformations. Alright, for number 19, the name of that one is going to be called a rational function. The effects, well, we know this asymptote originally should be at the y-axis, but it's moved over 1, 2, 3, 4 spots, so that's right 4. And other than that, that's actually all that we can see that's taking place. So now we're going to write out the transformation equation, y equals a over x minus h plus k. Alright, so I did go to the right 4. That's going to be your h value, which should be right here. So y equals a, if there's no number of reflection, we count that as a 1 over x minus h. So in this case, right 4 would be minus 4. Since there's no plus k, no k value, don't put plus or minus any number. Let's take a look at the next one. Alright, for the next ones here, again, we just have more functions. This right here is the exponential. If you recall, it has a horizontal asymptote. That's supposed to be the x-axis, not the y-axis, or not that far down. So the transformation, we can see the asymptote went from 0 for x, 0 for y, down to 1, 2, 3, 4. Y went down 4 units. So now it's at y equals 4. Now the the transformation here is y equals a times e raised to x minus h plus k. Well, down 4 is going to be your k value, so we're only going to have this one right here. Okay. So y equals, there's no a, so we leave it alone. E we do need, which is x minus h, but there is no h value. We have a k, so it's just e to the x. And then plus k becomes down 4, which is minus 4. And there's our equation for the number 20 exponential function. Now for number 21. This is called a cubic function. You can also call it polynomial odd if you'd like. The effect, well, this originally, the dot in the middle should have been at 0, 0, the origin, but notice it's gone right 2 and up 1. All right, so for the cubic function, y equals x minus h, sorry, let's try that again. Y equals a times x minus h cubed plus k. All right, so first off, we have a right 2 and we have an up 1. So we have no a value, so right 2 is h, up 1 is k. So therefore, a, we don't put a number, so y equals, it's going to be blank, x minus h cubed. So in this case, our right 2, so when we plug that in, it's x minus 2 cubed, and then plus k, which would be up 1. So plus 1. And there's our equation for that. All right, next for number 22, pretty much what we're doing is we're taking the transformations and we're seeing what they do. So first off, the easy one is up 1. Next thing I see, we have a negative inside, and that's going to be a reflection across the y-axis. So that's first transformation. The second one, I see this the third one, I have a 4 here. So the negative reflected across the y-axis. The 4, since it's inside being multiplied x, we're going to flip it over. And then we are going to figure out if it's a stretch or a compression. This one is less than 1/4, so it's compression. And then it's inside there with the x, so that's going to be a horizontal compression by 1/4. All right, and for number 23, we have this negative sign here. That's a reflection across the x-axis. So don't get that confused. It's not -2 for transformations. It's the negative sign by itself. Now the 2 right here, the 2 is greater than 1, so that's going to be a vertical stretch by 2. Inside we have x plus 3, so that's going to be your h's. So we move it to the left to 3. And then the minus 8 on the outside of the radical makes it go down 8. And then last but not least, after this, you do have these parent functions to kind of look over and memorize if you need to. Knowing the name, equation, domain, and range, and what the graph looks like. That completes the review.